Okay, so let's take a look at this Unit 2 practice test. We've been talking about how to solve systems of equations in this unit. So remember, always make sure you show your work and what you're thinking as you're solving these. Write our answers in correct forms. Make sure we pay attention to the instructions and circle our answers. So we're going to solve each system below by graphing. So that's the technique we're going to use. Describe each system using the appropriate vocabulary words here. So consistent, inconsistent, dependent, independent, all that sort of stuff. And then this is important. It's underlined. Label at least 2 points on each line. So you'll notice on this first one, both of these are in slope-intercept form. Remember, y equals mx plus b. So this first one, I'm going to do that in red. So I'm going to slide this down just a little bit. And we're going to make this cross at 2 on the y-axis. So we cross right here. And then remember, the coefficient in front here is a 1. So that means the slope is -1, meaning 1 over 1. So the rise is -1, and the run is +1. So we're going to go down 1 and right 1, down 1 and right 1. We're going to continue that pattern going this way, and then we're going to go back the other way. That's up 1 and back 1. So we've got this nice, perfect 45-degree angle going down from left to right, which is what we expect with a negative slope. So nice straight line here, put arrows on the end, and we're all set to go. I'm going to do this other one in blue. This one's going to cross at -5 on the y-axis, so we cross right there. And then the slope is 2/5, so that means we're going to rise 2 and then run 5. So rise 2, run 5. That's going to put me right here. That's good. Rise 2, run 5. That would have me over here. Let me do one more. Down 2 and then back 5. So we get this nice straight line. And it looks like this. We'll put arrows on the end, and then we can just see that this crosses right there. So that's our point of intersection. So the answer on this one is, this would be 5, -2. There's the XY pair. There's the point where the lines cross. Now, if you wanted to, you could graph this on your calculator and have it help you figure it out. So quick reminder here, it's always a good idea to reset your calculator. So I'm going to hit second and the plus button for memory, and then 7, and then 1, and then 2. It'll reset everything, have me right back to normal. I'm then going to hit y equals, and I want to put that -x and then +2. We'll hop down here and take a look at that one. I like writing this in as 2 divided by 5. I just find it a little bit quicker. Then I'm going to multiply that by x and then subtract 5. If you want to take the time to put the fraction in, that's totally okay. And then I'm going to just graph this in the standard window. So I'm going to hit the zoom button, just hit 6, that'll graph it in the standard window, and there we go. Looks pretty good. And then again, if we're going to have the calculator find the intersection point, we have to do some calculations here. So we're going to hit second and trace, or second calc. Number 5 is going to be the intersection tool. It says, is that the first curve? We say yes by hitting enter. Is that the second curve? We say yes by hitting enter. You can take a guess if you wanted to. If you wanted to use the arrows and kind of get a little bit closer there, that'd be okay. But with just 2 lines on there, we're going to be all set. Now, in this case, it's a really good thing I did this. This actually crosses. I miscounted. So a good lesson here. We always want to make sure we double check our work. On this one, had I just left that 5, -2, I would have gotten it wrong. So we've got this double checked right there. We're all set to go. So again, make sure your calculator has what you intend to put in there. Don't make any input errors there. And then always double check your work if you have time. So this was a good example where had I not double checked that, I wouldn't have gotten that right. So let's go ahead and enlarge this again. We'll take a look at the next problem. So again, the first one, I'll go ahead and put that in slope-intercept form so I can graph that. I'll do this one in red. I'm going to move the 2x to the other side by subtracting 2x. So that's going to be -2y equals -2x minus 8. We'll divide both sides by -2. So those are going to cancel. Again, I can break this into 2 parts because the numerator has those 2 pieces. If you want to do them individually, that's totally okay. I end up with a +x, and then I end up with a +4. So I'm going to go ahead and graph that right now. That crosses at 4, and then the slope is +1 here. So we rise 1 and run 1. So we're going to get this nice, perfect 45-degree angle going up from left to right. So there we are. And I'll do this next one in blue. So on this one, all I need to do is move that x to the other side. I just do that by adding x to both sides. So I get y equals, this would be x minus 6. So we'll graph this one. This one crosses at -6, and the slope on this one also is 1. So we rise 1 and run 1. And you might have an idea of what's going to happen here. These are both parallel lines. These are never going to cross. So there's a couple different ways that we could think of this. We could say no solution. No solution is one way we could write the answer. So I'm going to write no solution here. Okay. Another way that we could write this, like they said up here, is we want to use the appropriate vocabulary, the words that we learned in this unit. So if this doesn't have any answers, then what we say is this is inconsistent. So I'm going to write down inconsistent. Okay, so there's the answer that we're after. So we've got this graph that indicates what's going on here. Hey, they never cross. We're trying to find the point where the lines cross. They don't, so we say there's no solution, or better yet, in this case, we say it's inconsistent. So I'm going to slide down to the bottom of the page. Now these two problems, 3 and 4, notice it does say we want to solve these using substitution. So I'm going to go ahead and solve this, and you'll notice that this one is already solved for y. So wherever there's a y, we're going to put negative 6x minus 8. So I'm just going to put that stuff right here. So I'm going to rewrite that second equation, negative 5x plus 2, and then in place of the y, so I'm going to replace that y entirely. I don't put y, I put what y equals. So that's negative 6x minus 8. And then on the other side equals 18. So you'll notice that this second equation has now been rewritten. I've rewritten it with the negative 5x. I've got 2 times y, but I've replaced the y with what y equals. So now I've got just x's in this equation and numbers. So we'll just continue solving now. I do need to distribute here. So we end up with a negative 5x. We get negative 12x, and then we've got a negative 16. And then on the other side, we have an 18. And then we put the two of these together, we get negative 17x minus 16 equals 18. We'll move that 16 to the other side by adding 16. So we have negative 17x equals, and when we take 18 plus 16, we end up with 34. So I'll just finish this off by dividing both sides by 17. Negative 17, that is. And then I end up with x is equal to, let's see, a positive divided by a negative is a negative, and 34 divided by 17 is 2. So we've got one of the answers. Now I'm going to go ahead and make that a dotted circle around here because that's not really quite the whole answer. Now I'm going to take this and I'm going to plug this into one of these equations up here, and it's usually easiest to plug it into the one that already had a variable solved for. We know what x is. We're trying to find y. So I'm going to take this and I'm going to put it right there. So we get y equals, this is going to be negative 6, and x was negative 2, so we're going to plug in a negative 2 for x, and then minus 8. This is going to be a positive 12 minus 8, so we get y equals 4. So this is the other part of the answer. There's what y is. So the final answer on this one would be the xy pair, negative 2 comma 4. If we were to graph the two of those, that's where those lines would cross. So let's take a look at the next one. Again, this one says solve using substitution, so you may be inclined to think, oh, I'd rather solve this one using elimination. Definitely want to solve this one using substitution. So the easiest variable to get by itself is not the 2x, it's not the 7y over here. This x right here looks like a good candidate because it's just a plain old 1x. And if we wanted to get that second y by itself, that negative 2y, you'd have to divide by a negative 2, and that would end up making fractions here. So what I'm going to do is I'm just going to add 2y to both sides here. And we end up with x is equal to, and I'm just going to write the y term first. So this is going to be 2y plus 1. So now wherever there's an x, I'm going to put 2y in its place. Now we always want to plug into the other equation. We don't want to plug into the second one because that would be like going around in circles. So I'm going to take this and I'm going to plug it in right there. So we end up with 2 times x, which is 2y plus 1. And then we have the plus 7y. And then we have the equals 2. So we're going to distribute. So this is going to be 4y plus 2 plus 7y equals 2. We'll combine these like terms right here. So we get 11y plus 2. And that's going to be equal to 2. Keep solving here. So this is going to be subtracting 2 from both sides. Those are going to cancel. So we get 11y on this side. And then on the other side, we've got 2 minus 2. So that ends up being 0. Now, some people, again, freak out when they see a 0. Nothing wrong with that. 0 is just as good a number as anything else. So we end up with y equals, let's see, 0 divided by 11. Now, remember, you can take 0 and you can divide by a number. So 0 is okay on the top. It's not okay on the bottom. So we get 0 right here. So I'm going to put a dotted circle around that, and then we're going to go find the other one. So if I know y is equal to 0, wherever I see a y, I can put a 0. So I'm going to take this, and I'm going to put it right there. So this is x equals equals 2 times, remember y is 0, so I'm going to put a little 0 right there, plus 1. We end up with, this would be 0 plus 1. So that's going to be x equals just a 1. So I'll put a dotted circle around that right there. And we're going to write the answer as an ordered pair. So this is going to be 1, comma, 0. Circle that because that's our answer. Okay, let's take a look at the next page. All right, these two problems, 5 and 6, ask us to solve them using elimination. So let's take a good look here. This number 5, gosh, this is cool. Take a look here. The x's won't go away if I just add those together, but notice on the y's, we've got a 4y and a negative 4y. Same coefficient, but opposite signs. So if I were to just draw a line right here and add these together, I get a negative x, and then on the other side, I end up with a 4. Now again, be really careful with these. Don't just leave an x there. Don't drop the sign or anything like that because you definitely get the answer wrong. We don't want negative x, we want positive x. So technically we're going to divide both sides by negative 1. We end up with x equals negative 4. So the cool part about elimination is many times it's quicker. A lot of people like it better. So I'm going to take this and I'm going to plug it back into one of the original equations. It really doesn't matter which one. I'm going to plug it into the one with a positive coefficient right here. So I'm going to plug it in right there. So I get 6 times negative 4, then minus 4y equals negative 16. So this is going to be negative 24 minus 4y equals negative 16. We're going to go ahead and add the 24 to both sides. And we've got a negative 4y. Let's see, negative 16 plus 24, that's going to be an 8. We're going to divide both sides by negative 4, and we get y equals negative 2. So again, you'll notice that elimination does tend to go a little bit quicker. So on this one, we're going to write the answer, negative 4 comma negative 2. Circle that. That's our final answer. I'll make that one look a little bit more like a 4. And we'll take a look at the next one. Now on this one, we don't get quite as lucky, so let's take a good look here. We've got a 2x, a negative 2x, and we've got a positive 8x. We could turn those both into 8s. Okay, we could turn that 2 into an 8, or we could turn that 5 into a 10. That would work also. Now, really doesn't make any difference. I like changing that top one for sure. So here's what I'm going to do. I'm just going to multiply this top one by 4. Now, if you're thinking, hey, why are you turning that into an 8 when you could just multiply by 2 and that would turn that into a positive 10 and that would cancel? Really just personal preference at this point. It doesn't matter which one you eliminate, just whichever one you find easier. I'm going to go ahead and get rid of this x. So here's what's going to happen. We're going to multiply here, here, and here. So we end up with a negative 8x. 4 times 5, that's going to be a plus 20y. And then we're going to multiply on the other side. 4 times negative 11, that's going to be negative 44. So then I go ahead and combine the two of those bottom ones. Again, I'm kind of ignoring this one on the top. I'll put just a little line through that right there. So we're going to put the two of those together. I get no x's. 8x minus 8x is 0x, so I don't have any x's left. Negative 10y plus 20y, that's going to be 10y. And I have 54 minus 44, so that's going to be 10. That makes a nice, easy equation to solve, so I get y equals 1. So we know what y is, and now we'll take this and we'll plug it back in and we'll figure out what the x is. Again, doesn't make any difference which one I plug it into. I'm going to plug it into the one with the smaller numbers, even though I've got a negative to worry about. So this is going to be a negative 2x. This is going to be a plus 5, and y is 1, remember. And then on the other side, we've got a negative 11. So let's have that negative 11 over there. So let's see, we have a negative 2x. We've got a plus 5. That equals negative 11. We're going to subtract 5. So we have negative 2x equals, let's see, negative 11 and negative 5. That would be negative 16. We're going to divide both sides by negative 2. Those are going to cancel, and we're going to end up with an 8. So we've got an x here, and we've got the y right there. So we're going to go ahead and write down the answer of 8, comma 1, and we'll circle that, and we're all set to go. So we'll take a look at number 7 and 8, and look how nice they were on this one. It says you can use either substitution or you can use elimination, but it does say we need to use proper vocabulary to describe the answer, so let's make sure we do that. Now, I think I'm going to do one of these using substitution, the other one using elimination, so let's just see how that goes. I'm going to take this one, I'm going to eliminate. I'm going to take this and kind of look at it and say, hey, I could turn both of those into 70s, Or if I've got a 5 and a 7, I could turn both those into 35. So I'm going to turn those into 35s. That'll keep things a little bit smaller. I'm going to multiply this one by 7. So this is going to be 7 times 7. So we're going to end up with 49x. 7 times 5 is 35y. And then on the other side, we've got 7 times 19. Now, no shame if we've got to grab the calculator. I'm going to clear this off, go back to the home screen and all that sort of stuff. I'm going to shrink this down, so we'll play around with this just a little bit. So 7 times 19. Now, you might be making an argument that, hey, if we had turned these into 70s, maybe that would have worked out a little bit better. We're probably going to be using our calculator no matter what. So this is going to be 133 there. And now we'll multiply this other one. Remember, we want to turn this into a negative 35. So we're going to multiply by 5. Hopefully that's a little bit easier. So this is going to be a negative 50x, a negative 35y. And then on the other side, I've got 5 times negative 26. Well, I know that's going to be negative, but let's just double check on the calculator. 5 times negative 26. So we end up with negative 130. So negative 130 here. Now I've got something that I can just eliminate. Those y's go away. And let's see, 49x minus 50x, that's negative x, negative 1x. And then on the other side, we have a, let's see, 133 minus 130. So that's going to be a 3. So we've got x equals negative 3. Make sure we keep track of that negative right there. And then we're going to take this and we're going to plug it in. Now I'm going to make this bigger and see how this works out. So we'll take this and we'll plug it in. Again, doesn't matter where we plug it in, but I am going to plug it into that first one. A little bit smaller numbers and not as many negatives. So we're going to take this and we're going to plug it in right there. So this is going to be 7 times negative 3 plus 5y equals 19. So this is going to be negative 21. And let's see, plus 5y. There we go. And on the other side's a 19. So we move the 21. We're going to do that by adding 21. And then I get 5y equals, let's see, 19 plus 21. So good, this is going to work out to be a nice number when we divide by 5. We end up with y equals 8. So this is the other one. So the answer on this problem is negative 3. So I'll change that to red to kind of stick with what we've been doing. Negative 3 comma 8. So there's our answer, but remember, they want us to use the right vocabulary on this one as well. So remember, if it has an answer, we call that consistent. So this is consistent and it's independent. Consistent and independent. So we'll take a look at this next one. And again, this one's just personal preference on how you do this. You can use substitution or elimination. I'm going to go ahead and do elimination on this one. I'm going to move that x to the other side by subtracting x. So I get y equals, let's see, this would be negative x plus 4. And you might be thinking, hey, why don't we just do this one using elimination? I think that would be easier. You're totally welcome to. You'd still get the same answer as I'm going to get. So wherever there's a y, we're going to put negative x plus 4. So I'm going to put that in right there. So we end up with, let's see, we've got 10x, and then we're going to do plus 10. And then in parentheses, we're going to put what y equals. That's negative x plus 4. And then over on the other side, we've got that 40 right here. So let's see, we distribute through, and we end up with 10x. This would be a negative 10x, and then plus 40 equals 40 on the other side. So these two cancel each other out, and we end up with 40 equals 40. Now, if we end up with two numbers that are equal to each other, so the variables are gone, there's not an x, there's not a y or anything like that, we just have an equation that says 40 equals 40. Well, remember, that's always true. There's nothing we can do to mess that up. So this would have infinitely many solutions. Now, what that means is these two lines are right on top of each other. So rather than say infinitely many solutions, we're going to use the appropriate vocabulary here. So I'm going to write infinitely many solutions just to kind of remind us of that. So infinitely many solutions, okay? But the best vocabulary on this one is to say that this is consistent. So consistent, and it's also dependent. So we'll write dependent here. All right, so that's how we do that one. This would be the best answer, right vocab and all that sort of stuff. So let's take a look at the next page. Okay, we get to do some story problems now with this whole systems of equations. So it says read the problem, then follow the steps to help you set up this system and solve to find the answer. So it says at a spring garden sale, Mark bought 3 rose bushes and 7 flats of petunias for a total of $114.75. Cynthia bought 2 rose bushes and 6 flats of petunias for a total of $89.50. How much does each rose bush and each flat of petunias cost? Now, remember, most story problems end with a good question, or they leave you hanging, wondering some question that's kind of burning, or, you get wondering, hey, what's going on with this? So on this one, what we're going to do is, because they mention roses first, and it says how much does each rose bush and each flat of petunias cost, I'm going to put a $sign here to remind us that we're looking for an amount of money here. So the $sign, and this is going to be for rose bush. Okay, so how much does a rose bush cost? And then Y is going to be how much the petunias cost. Petunias. Now, if you were doing this on your own, you could use R for rose bushes and P for petunias or something like that. What we're going to do next here is we're going to write an equation that represents Mark's purchase. So Mark's purchase was 3 rose bushes and 7 petunias for $114.75. So X is the rose bushes, so we're going to write 3X. And then we're going to add the 7 petunias, so that's going to be 7Y. And how much did he spend altogether? $114.75. And then it says write an equation that represents Cynthia's purchase. Well, Cynthia bought 2 rose bushes, and then she bought 6 flats of petunias for a total of $89.50. So we're going to do 2 rose bushes, so that's going to be 2X. And 6 petunias, remember petunias are Y, so this is going to be 6Y equals $89.50. Now, that's a lot of the work and thinking that goes on here. So I'm going to come down here and it says write the 2 equations above together to make a system of equations. So we're kind of stepping through this. So I'm just going to rewrite those here. So I'm going to rewrite this as 3x plus 7y equals 114.75. And 2x plus 6y equals 89.50. So I've got my system of equations put together here. Now we get to choose how to do this. But let's take a pause right here. This right here is the hardest part. If you can get to here, you can solve the rest of this problem, because all we need to do now is either substitute or eliminate. I'm going to choose to eliminate on this one. So I'm going to eliminate the x's. So this is what I'm going to do. I'm going to multiply this one by 2, and I'm going to multiply this one by -3. So here's what I get. When I multiply by 2, I'm going to get 6x plus 14y, and then I'm going to multiply those together, or multiply 2 times 114.75. So 2 times 114.75, and we end up with 229.50. So I'm going to keep that 50 cents on there just so I can keep track of that. And then I'm going to multiply each one of these by the -3. So this is going to be a -6x, a -18y. Again, the other side's pretty easy. Now we've got to do -3 times 89.50. So let's clear this off, and let's do -3 times 89.50. So we end up with 268.50, -268.50. Okay, now we'll go ahead and add those together because that'll eliminate the x's. And we're going to end up with a -4y. And then on the other side, let's see what we get here. I'm going to do the -268.50, and then I'm going to add 229.50. Okay, so that gives me 39, so -39. Now, we might look at that and go, hey, wait a minute. This seems a little bit weird because we're used to getting whole number answers on here. So if I plug this in here and I do -39 and I divide that by -4, I'm going to end up with 9.75. 9.75. Whoops, got to get that in the right order. 9.75. So this right here is the answer, and we might think, well, that's weird. But remember, this is the price of petunias. Take a look up here at what y is. Y is the price of petunias. So that's perfect. That's $9.75. All we need to do now is we just need to find out what the price of a rose bush is. So I'm going to take this and I'm going to plug it into the easiest equation I can find. I think it's probably this one right here. So this is going to be 2x plus 6 times 975 equals 89.50. So we'll grab the calculator. We're going to do 6 times 975. And we end up with 58.50. So 2x plus 58.50 equals 89.50. And we'll subtract the 5850 from both sides. So we're going to subtract 5850. Okay, that goes away from there. Let me slide this down just a tad. So we end up with 2x equals, and we'll see 8950. You can probably do this in your head. Minus 5850. Make sure that the calculator's got the right thing in there. 31. So we do 31, and then we're going to divide by 2. So we get x equals, and again, you could probably do that in your head, but I'm going to divide by 2. Just double check and make sure on my calculator. So I get 15.5, but remember, that's a dollar amount. So I'm going to put a little circle around this right here. I'm going to shrink this down so we can see the whole page all at once. And we need to write down an answer to the problem. Well, the question was, how much does each rose bush and each flat of petunias cost? Well, now that we've got this, we know that y is the cost of the petunias. This would be $15.50 for the rose bushes. So we're going to write this down in a sentence. Rose bushes cost $15.50. I'll make my 5 look like a 5. Get that to erase there. Okay. And what do we say for petunias? So petunias are $9.75. And petunias, and these are flats of petunias, I'm not much of a gardener, are $9.75. Okay, so there's our answer. So long problem, but we can handle that. Let's go ahead and take a look at the next one. Okay, some of my favorite problems are like this. So a farmer has a total of 43 animals in his barn. Some of the animals are chickens and some are cows. If there are 114 legs in the barn, how many chickens and how many cows does the farmer have? So I'm going to do C for, wait a minute. If we did C for chickens, we'd have to do C for cows. So let's do this. This is why it might be a good idea to stick with the X and Y. So this is going to be chickens, and I'm going to put a little number sign there. So the number of chickens, and Y is going to be the number of cows. And if there are 43 animals altogether, we're going to do X plus Y equals 43. So that equation is about the number of animals. Number of chickens plus the number of cows, we get 43. And then we know chickens have 2 legs, so we're going to do 2 times every chicken plus 4 times every cow, and we get 114 legs altogether. So I'm going to go ahead and multiply this one by -2 because I'm going to eliminate that x right there. So this is going to give me a -2x, a -4y, and let's see, a -2 times 43, that's going to be a -86. So now we can combine those together. The x's go away, but we're left with, whoops, not a 4y, but a 2y. And then on the other side, again, I'll just double check on the calculator, 114 minus 86, we end up with 28. So 28 right here, we'll divide by 2, so we get y equals 14. We're going to keep solving this, so I'm going to take this and I'm going to plug that in right there. Now, you might be able to look at this and think, well, hey, wait a minute. If y is the number of cows, we should just be able to do a subtraction problem and figure out how many chickens there are, which is true. If you wanted to, you could just do that, and we end up with x equals 29. So x is the number of chickens, y is the number of cows, so we're going to write down the answer. 29 chickens and 14 cows. Circle that and we're all set, and now it's time to look at the last type of problem. Okay, so this is where we're going to solve a system of inequalities by graphing, and we're going to definitely want to label the point where the lines intersect. Notice that we've got x is less than or equal to 3. X equals a number is a vertical line, so that's going to be a vertical line at 3, and that's going to be a solid line. So we're just going to draw that line right there. And remember, we read from the variable, so we're talking about x's that are less than or equal to 3. So we're going to be shading on this side right here. So I'm just going to put a little bit of shading over there just so I can keep track. So we've basically kind of narrowed ourselves into the left side of this graph. Then I'm going to change colors and I'm going to graph the other one. This is y is greater than -2x. So if we wanted to think of that in slope-intercept form, there's really a 0 right there. So it crosses right at the origin, and then we're going to rise 2, or take that back, rise -2. So we're going to go down 2 and then forward 1, because that's 2 over 1, down 2, right 1, down 2, right 1, and then we're going to go up 2, back 1, up 2, back 1, so it's going to look like this. And this is a dotted line right here. So we'll do a dotted line. Okay, and then this is y is greater than that. So I'm going to put my pencil anywhere on the line, and then remember the y-axis goes up or down. So if the y's are greater than, we're going to go above the line. So we shade this side of the line right here. Okay, now the only part of this that's shaded by everything would be all of this stuff in between here. So we're going to go like this. That's the answer. We want to make sure everybody's perfectly clear on what we think the answer is. And then we also want to say the point where they intersect. So these happen to intersect at 3 comma, this would be 3 comma negative 6. So 3 comma negative 6 is the important point there. Let's make sure we put that. Okay, let's come over and take a look at this next one. These are both in slope-intercept form, so that's good for us. This one has a y-intercept of 0, so it crosses right here. And the slope would be 4, so we're going to rise 4 and run 1, rise 4 and run 1. We're going to go down 4 and back 1, down 4 and back 1, so it looks something like this. It doesn't have the little bar on it, so it's not equal to, so I'm going to draw a little dotted line right here. And its y is less than that line, so we're going to be shading down below here. So just do a little bit of shading on that side right there so we don't make this too ugly. So basically what we're doing is we're limiting ourselves to this side right here. I'll just shade that in for just a second so we can see that. And then the other one, this one crosses at negative 3, so we're right here. And then the slope of this one is 1, so we would rise 1, run 1, rise 1, run 1. So we're going to go like this, put a bunch of points there. Down 1, back 1, so it's going to go like this. And then this one is a solid line. So we do a solid line right here. And then we're going to shade below because this is y is less than that line. So we would go down below here. So we're going to shade over here. Okay. Now, one way that we can do this is we can say, hey, see this area that doesn't have any shading over here? The opposite one would have both types of shading. So we see the blue shading along here, and then we see the red shading over here. So the answer on this one is going to be this shaded region right here. Okay, so we'll shade that in. And that's what we're after right there. Now, we do want to indicate the point where they cross. So I'm going to put a dot right here. They cross at negative 1 comma negative 4. That's the point where they intersect. So we've got a solid line along here, along that blue line right there, and then a dotted line right here, and then it's everything over in this region. Now, if you wanted to use a calculator to graph these, you would be certainly welcome to do that. That can really help. Always a good idea to double check. We might do that on some of these other ones right here, but let's go ahead and take a look. So on this first one, I'm going to move the x to the other side so we can get that in slope-intercept form. So this is going to be negative y. Subtracting doesn't change the direction of the inequality. So we've got negative x plus 4. And then we need that y all by itself. So we're going to divide both sides by negative 1. So this is going to be y is, and when we divide by a negative, we have to switch that around, greater than or equal to. This would just be x minus 4. So this one's going to cross at negative 4, and it has a slope of 1. So rise 1, run 1, rise 1, run 1. So it's going to look something like this. And it's equal to, so that's going to be a solid line. So I'm going to draw a solid line right here, like that. And its y is greater than that. So I'm going to do a little bit of shading above this right here. Okay. All right, let's take a look at the other one. We need to get the y by itself, so we're going to subtract the x again. So that's going to give me a 3y. Whoops, I need to change colors here. Let me make that look right. Okay, so we get a 3y. Subtracting doesn't change the direction, so I get a negative x plus 6. Again, I'll write the x first, just so we put that in slope-intercept form. And then, like I said before, if you want to divide it in different pieces, that's totally okay. Dividing by a positive doesn't change the direction of the inequality, so we get negative 1/3 x, and then this would be plus 2. So we're going to graph that one. Crosses at 2, and then we're going to go, let's see, we go down 1 and back 3. Down 1 and forward 3. Down 1 and forward 3. So it looks like this. Up 1 and back 3. Up 1 and back 3. So we're going to go ahead and draw it. Whoops. This is not a solid line. This is a dotted line. Okay, so we'll do a dotted line right there. And then we're going to shade below because this is y is less than. So if we shade below the line, that's going to be this area right in here. So I'm going to make clear that this is the answer. Whoops, let me make this black like I did on the other ones. So this needs, ooh, here we go. Let's make that, there we are. Okay, so that right there is the answer. That's our region. Now, we want to know where those cross, so we're going to have the calculator help us out on this. So I'm going to pull this up, shrink this down here. I'm going to clear this off, and I'm going to hit y equals. Clear each of those off from when we graphed before, and we're going to type in the red one. So this is going to be x minus 4. And then the blue one down here is negative 1/3. Now, I didn't do fractions before. I'll go ahead and do a fraction on this one. So I hit alpha y equals. I want to put in the fraction negative 1/3. Hop over here, put the x there. Now you can see why I think this takes a little bit more time. Hop down there, make sure everything looks right on this. It does. So we're going to go ahead and graph. All right. Now, if you wanted to take the time to do this, we can actually go over here and we can tell this one, hey, we want to shade above there. So we can hit the enter until it shades the right direction because we wanted to shade above there. And then on the blue one, we wanted to shade below. So we'll toggle through the options here. And that looks good, and we'll hit graph. Okay, so excellent. This is what we expect. This dark region right here matches up with what we have here. So I'm going to go ahead and hit second trace to calculate the intersecting point. So I'm going to hit, yep, that's the first curve. Yep, that's the second one. If you want to guess, you're welcome to. So we end up with 4.5, 0.5. Well, we want to answer in fractions since that's the way this problem was written. It didn't have fractions or decimals in the problem. So this point of intersection right here is going to be 9/2, comma, 0.5 would be 1/2. Now, I'm going to go ahead and enlarge this, and let's take a quick look. Once we get a good look at this, does that look like about 4.5, 1/2? It does. Looks pretty good there. Okay, last problem we'll take a look at. On this one, it's already in slope-intercept form, so I'll go ahead and graph that one in red. This one crosses at -3, and the slope is 5/2. So we're going to go up 5 and then over 2. And we're going to go up 5 and over 2. So we get to right there. And then let's see. This one we need to get the, oh, I need to draw the line. So that is going to be a solid line like that. And we would go down 5 and back 2 in order to get to this other point right here. And let's see, y is less than that line. So we're going to shade on this side of the line. Okay, so we've effectively narrowed ourselves in and said, hey, the answer's got to be somewhere over in this area. Okay, so that's all we're looking for as part of the answer. And then this other one, I'm going to put this in slope-intercept form, so I'm going to subtract the x. So this is going to be 4y. Subtracting doesn't change the inequality, so this is still a less than or equal to. I'll do the negative x first, then plus 32. And then we're going to divide everything by 4. So if I do that, I get y is, and we're going to have a less than, this would be -1/4 x, and then plus 8. Okay, so let's take a look here. This would cross at 8, so that would be right there. And then we would go down 1 and right 4, down 1 and right 4. And this is a solid line. Okay, so the solid line looks like this. And then y is less than, so we would be below on this one also. So the area that would be below below both of them is this area right here. Okay, so that part is the answer. And then we want to put that intersection point right there. Again, if you wanted to have your calculator help you out, that'd be totally okay. This one I think we can find, that would be 4,7 if I'm not mistaken. So 4,7 is the coordinate where those intersect. Okay, so we want to have that on there as well. Okay, so that's how we do these problems. Good luck on the test. The test probably will be shorter. If you can do this stuff, you're in great shape on the test. All right, good luck.